Now we get into factoring harder trinomials. What makes these trinomials harder is that they don't start with just a regular x squared, they start with a 2x squared, or a 3x squared, or 4x squared, or so on, some number in front of the x squared. That makes them a little bit harder. Now there's lots of different ways to factor these harder trinomials, but I'm going to show you a method which I call the bad math method. And the reason I call this the bad math method is because it actually uses a step that's mathematically incorrect, but then we fix it later on. Now, in this first example, we're starting with the 2x squared. What you do in this method is you start each parentheses with what you saw in the beginning. We started with 2x squared, so we're going to start each parentheses with a 2x. Now this is mathematically incorrect, and that's why I call it the bad math method, is because 2x times 2x would give you a product of 4x squared. We had started with a 2x squared. We're going to fix this problem later, but just know that we're technically doing something that's not mathematically correct. And the next step we do is we take the first number, which is 2, and multiply it by the last number, which is 12. 2 times 12 is 24. Make a list of things that multiply together to make 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Focusing in on our middle number, we have an 11, and we want to pick the pair of numbers on this list that add up to make 11. That would be the 3 and the 8. So our factors right now are 2x plus 3 and 2x plus 8. Now we're almost done, but not yet. We have to fix the bad math we did at the beginning. Look at your second factor. 2x plus 8 has something that can be reduced about it. 2x and 8 have a 2 in common. It's the greatest common factor. And so what we do is we just take that greatest common factor and we divide it out from each term. We divide the 2x by 2 and we divide the 8 by 2. When I reduce that down, it leaves me with x plus 4, and so my final answer would be 2x plus 3 and x plus 4 as my factors. Look at the next one. We start with 2x squared, so we're going to start each parentheses with 2x and 2x. Multiply the first and the last numbers together. 2 times 6 is 12. Here's a list of things that multiply to make 12. What pair of numbers on that list would add up to the middle number, which is -7? Well, the 3 and the 4 would both work if they were negative. And that's what we're going to use. 2x minus 3 and 2x minus 4. Now one more step. Don't forget to go back and fix the bad math that we started with. Our second factor has a common factor of 2. We're going to divide 2 out by the 2x and by the minus 4. When we do that, it reduces down to x minus 2, and so our final answer will be 2x minus 3 times x minus 2. Try the next two problems and see if you can do these. Pause until you're ready. The beginning of our first problem is 3x squared, so with the beginning of our answer, we want to start with 3x and 3x. Multiply the first and the last numbers together. 3 times -12 is -36. Here's a list of things that multiply together to make -36. What pair of numbers on that list would add up to -16 in the middle? Well, that would be the 2 and the -18. So we want to pick 3x plus 2 and 3x minus 18 to be our factors. Now one more step, go back and fix the bad math that you used at the beginning. Your second factor has a common factor of 3 in it. Divide that out or reduce it if it helps you to think about it like reducing it, and that reduces down to x minus 6. So 3x plus 2 and x minus 6 is our final answer. On the next one, we started with 4x squared, so we're going to start each parentheses with 4x and 4x. First number times last number gives us a product of -24. Here's a list of things that multiply together to make -24. Pick the pair of numbers that add up to your middle number of 5. Well, that would be the -3 and the 8. So your factors are 4x minus 3 and 4x plus 8. One more step. Go back and fix the bad math that you started with. Our second factor has a common factor of 4 in it. We can divide 4 into each one of those terms and reduce it down, leaving us x plus 2. So our final answer is 4x minus 3 and x plus 2. Now one more method. Factoring perfect square trinomials or difference of two squares. When your first term is a perfect square and your last term is a perfect square, try to factor by the perfect square method. Look at the beginning of the first problem. 4x squared is a perfect square because it's 2x multiplied with 2x. 9 is a perfect square because it's 3 multiplied by 3. So the correct way to factor this would be 2x in each parentheses and 3 in each parentheses. 2x plus 3 and 2x plus 3. Now you might be saying to yourself, well, where does the 12 come in? If you take the outer product of 2 and 3 and the inner product of 3 and 2, you get 6 in each case. And if you add up 6 and 6, they add up to 12, and that's where that comes to in the middle. Look at the next one. We begin with an x squared. That's a perfect square. X times x. We end with negative 64. That's a perfect square. 8 times negative 8. These are our factors. X plus 8, x minus 8. Now you might be saying to yourself, well, this one looks different than the first one. There's no middle number. That's because the positive 8 and negative 8 are working to cancel each other out, and that's why all you have here is a beginning to the problem and an end with no middle term, no regular x's in the middle. You just have a beginning and an end but no middle. Look at the next one. Try and see if you can factor this one, and then we'll go over it together. The first term is a perfect square. It's 5x times 5x. The last term is a perfect square. It's 9 times 9. Our factors will be 5x in each parentheses plus 9 in each parentheses. 5x plus 9, 5x plus 9. And again, you might say to yourself, well, where does 90 come from? Look at the outer product of 5 times 9 and the inner product of 9 times 5. 45 in each case. Add up 45 and 45 and you'd have 90 in the middle, and that's where that comes from. On the next problem, we start with 4x squared. That's a perfect square. 2x and 2x. And we end with negative 49. That's a perfect square. 7 times negative 7. When I factor this, I want to factor it as 2x plus 7 and 2x minus 7. Notice I had just a beginning and an end with no middle term, and that's because the positive 7 and negative 7 are working to cancel each other out, leaving me just the beginning and the end with no middle. Look at the special note at the bottom. If you start with a perfect square and you end with a perfect square and you have no middle and there's a plus sign, they don't factor. It's prime. So for example, x squared plus 9. Beginning is an x squared, that's a perfect square. Ending is 9, that's a perfect square. We have a plus sign between them, not a minus sign, and we have no middle term. So this does not factor any time. Try these next three for practice. You're going to begin by taking out a greatest common factor and then continuing to factor each one of them. Pause until you're ready to go over them. Okay, looking at the first problem, we're going to take out a greatest common factor, which is 6. Remember, greatest common factors go in the beginning of the parentheses. Now we look and see what's left over from each term. From our first term, when we take out the 6, I still have x squared left over, and then in the second term, when I divide out by 6, I have 36y squared left over. That came from taking 216 and dividing out by 6. Look at what's left over in parentheses. This can still be factored. X squared minus 36y squared is not factored completely. It can still be factored more. These are perfect squares. We can break them up by the perfect square method. X squared would break up into x and x. Negative 36y squared would break up into positive 6y and negative 6y. So our final answer will look like this. 6 out in front for the greatest common factor, and then our perfect square factors were x plus 6y and x minus 6y. We used two methods there in that problem. Look at the next one. Take out the greatest common factor, which is 2, and we'll have left over x squared and minus 16. Now you might think you're done, but you're not. Again, this can still factor what's left over in the parentheses. These are both perfect squares, and we're going to use the perfect square method to factor them. X squared breaks up into x and x. Negative 16 breaks up into positive 4 and negative 4. So here's how your final answer looks. 2 for the greatest common factor, and then parentheses x plus 4 and x minus 4 for the two perfect square factors. Look at the last problem. Don't jump right away to the perfect squares because you do have a perfect square at the beginning and at the end. However, I told you to always look for a greatest common factor first. And the correct way to factor this is to take out the greatest common factor, which is 4. Now, when you do that, we'll have x squared left over from the first term, minus 6x left over from the second term, and plus 9 left over from the third term. What's left over in parentheses is a trinomial, and this trinomial can still factor. Think to yourself, what would multiply to make 9 and would add up to make negative 6? Well, that would be a negative 3 and a negative 3. So our factors from the trinomial are x minus 3 and x minus 3. 4 will still be out in front as our greatest common factor. We use two methods on each one of these three problems.